In this video, I'm going to talk you through evaluating the uncertainty in a calculated gradient. So in order to do that, I'm just going to review calculating the gradient of a line of best fit. In physics, often what we're doing in our experimental investigations is trying to establish a relationship between some dependent variable on the y-axis and an independent variable on the x-axis. What we do is we take measurements of these two values and we plot those measurements as an x-y scatter plot. A set of data that looks like this, we would say, has a reasonably strong positive correlation. And what we can do is actually draw a line that passes through the center of this data. What we're going to do is just draw that line by sight. So we're going to take our ruler and we're going to place our ruler so that it passes through most of the points, or it passes through, if you imagine drawing a circle around the data that passes through the center of that circle. So we'll try and do that now. As long as you have a reasonable line drawn which passes above and below most of those points, that's going to be sufficient. Obviously, when you're doing an investigation, you can plot these points using Excel, and you can use Excel to actually draw in a line of best fit that's calculated using linear regression. The idea of that is what we do is we measure the distance between the points above the line, the sum of the points above the line, and we compare that to the sum of the distances between the point and the line that are below the line. And what we want to do is we want to draw our line in such a way that the distance between or the sum of all the distances between the points above the line is as close as possible to the sum of all the distances between the points and the line that are below the line. If we add each of these together, we want the sum of those distances to be a minimum. So that's basically how we want to draw our line of best fit. But as I said, it's sufficient for you to just draw in a line by eye. In our previous video, we were talking about uncertainties. So each of these measured values in an experiment would have an uncertainty, and that can be expressed using error bars. So error bars can be drawn in depending on the value of that uncertainty for each of those points. So if each of these horizontal lines was equivalent to 1 unit, then what we would have here would be basically the value plus whatever the uncertainty is and minus whatever that uncertainty is. So it would be about plus or minus, say, 0.8 of a unit. I think this graph represents about plus or minus 0.8 of a unit. I think we're getting a little bit ahead of ourselves. What we want to do is just review how to calculate the gradient of this line to start with. So the gradient is, you'll know from maths, the rise of the line over the run, or the change in the y value over the change in the x values. Now you can choose any 2 points on the line. I'm going to choose these 2 points. What we want to do is establish what is the change in the y value between these 2 points and what is the change in the x value between these 2 points. And we can then calculate our gradient. If these two axes have a uniform scale, the gradient of this line appears to be about 1. So we'd be expecting the change in y to be fairly similar to the change in x. So once we've calculated our gradient, it's important for us to be able to provide some sort of a indication as to what the uncertainty in that gradient is. So what we're going to do, what I will do is just redraw an example here. I'll put in a few points. I find it useful to draw a enclosure around the points in order to get a graphical or a visual representation of where the line of best fit might go. What we want to do now is consider the uncertainties in our measured values. So that will just correspond to half the smallest unit, or whatever uncertainty you've been able to calculate in your measured values. What we're going to do is we're going to draw in two more line of best fits. We're going to draw one that really will go to be the steepest possible line that we could draw. So I'm going to go from the bottom of our lowest uncertainty to the top of our highest uncertainty. Now I'm going to draw a line that has the lowest possible gradient that we could draw. So that's a line that goes from the maximum uncertainty on the low point to the minimum uncertainty on the high point. So now we've got three lines. This is our measured gradient. This is our line that has the maximum. Gradient. And this is the minimum gradient. What I'm going to do is I'm going to use these maximum and minimum gradients as our plus and minus value for our measured value of the gradient. So what we'll do is we'll work out what the minimum gradient is and what the maximum gradient is, and we'll compare that to the gradient of our line of best fit, and we'll see which one of these is further away from the measured gradient. So just to illustrate what I'm talking about, we'll do a little example. If we say that our measured gradient is equal to 1, our maximum gradient, so if we calculate that doing rise over run, if we get 1.2 for our maximum gradient, and if we get 0.9 for our minimum gradient, then that will be fine. Alright. These two lines aren't necessarily going to be symmetrical around our measured gradient. So in this case, the maximum gradient is 0.2 above the measured gradient, whereas the minimum gradient is only 0.1 below the measured gradient. Now the way we'll express our answer, our measured gradient, will be the gradient will be equal to 1 plus or minus, and we'll choose the absolute uncertainty that's the greatest. So in this case that will be 0.2 because this maximum gradient is 0.2 above the value that we measured. So in order to express an uncertainty in the gradient, we're going to calculate the gradient first, then using the error bars that we've drawn in that correspond to the uncertainty in our measurements, we'll add a maximum gradient line and a minimum gradient line, and we'll calculate the gradients of each three of those lines. We'll then identify out of the maximum and the minimum the gradient that is furthest away from the measured gradient, the gradient of our line of best fit, and the distance away from our line of best fit's gradient, that furthest away gradient will represent the uncertainty in our result. So in this case, the maximum gradient, 1.2, is further away from the measured gradient than the minimum gradient, which is 0.9. It's only 0.1 away from it. So we'll choose the maximum gradient because it's further away. It's 0.2 of a unit away, so we're going to then express our gradient as 1. That's the gradient of our line of best fit, plus or minus 0.2. And that's calculating the uncertainty in a gradient.